All right, folks, it's Bass Action, back in action here. In this video, we are going to introduce the law of cosines. Now, a couple things before we get too far, in case your paper is not already corrected. Down here, I want you to make sure that this equation has been corrected to look like this equation that is up here in the right. We want this to say cosine of C, and then a squared plus b squared minus c squared, and the denominator should say 2ab. So make sure that that is all corrected. We can even go ahead and correct our instructions and make sure that those say that we are going to solve for c, not b. Okay, now after we get that done, let's jump into our law of cosines and how this is useful. Now, typically this is presented in, you'll hear people say that we use law of cosines when we have a side angle side or a side 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 pattern. I prefer to think of this as I want to use this when there is no link. We've been working with our law of sines, and we know that we use law of sines when we have a link, where we know the measure of an angle and the measure of the side across from it. So we're going to take a look here at this, and we're going to set up this problem, and we're going to see what this means to have no link. So we're going to draw our triangle, just like we've been doing all along. It doesn't matter what our triangle looks like. We're going to put our A, B, and C on there. Doesn't matter that it's not to scale. Remember, lowercase a means that it's across from angle A, so that's going to be a 100. Lowercase b is across from angle B, and of course C, because that has the degrees, has to be the angle measure there of 40 degrees. So when we look at this problem right here, what we're going to see is that I know the side, but I don't know the angle. I know a side, but I don't know an angle, and I know an angle, but I don't know a side. So in no place do I have a link where I know the measure of the angle and the measure of the side across from it. That is how we know that we're going to use this law of cosines. Now, law of cosines is presented to set it up so that you could solve for any one of the angles. This is a little bit overwhelming to see three different versions of the same formula. So what we're going to focus on is really just one of these, okay? Now what we're going to do is we are going to call this a piece finger problem, because that's going to help us keep track of how to set it up without using a formula. So we're going to call this a piece finger problem, okay? And the way that's going to work is that when we look at this problem, we can see that we know this angle and we know these two sides across from it. So our piece fingers, literally, you are going to put your piece fingers, your first two fingers, you're going to put those fingers on the two sides here that you know, so that they surround the angle that you're given. So you would put your fingers right there, and for the rest of the problem, you are going to refer to these two sides as the piece finger sides. Now, when we go to solve this problem, we can't get a measure of any angle right away. So what we're going to do is we want to solve for this side. But when we look at our equations are set up to solve for an angle. So that's what we're going to do right here, is we're going to rearrange this formula so that we can solve for a side easily, and then moving forward, we'll be able to use this new formula. So we're going to solve this for C, because C would be this side right here. So I'm even going to put a C right there now, okay? So we're going to take this equation, we're going to solve for C, that's right here. What we're going to do is we're going to visualize that left side over 1, and then we're going to cross multiply. Now, how you write it will make it a little bit easier for yourself. So we're going to take this 2ab, and we're going to put that cosine C in parentheses. It doesn't have to be, it just is going to make it a little bit cleaner so that the C from the cosine doesn't run into the B and make you somehow confuse that as a side. So we've got that product, and that of course then is going to equal our a squared plus b squared minus c squared, and we're trying to solve for this c squared. So what we're going to imagine is that our c squared sorry, is going to move over here to the left. This entire term over here is going to move over to the right. So our equation is going to become c squared. We'll still have our a squared plus our b squared, and now we're going to have minus 2ab times our cosine of C. This is now beautifully set up to solve for C, and then all we would have to remember to do was take the square root when we're done. So let's apply that to this problem. I'm going to do that up here. So we're going to now solve for our C squared, and I'm even going to go ahead and I'm going to set this up as a C, and I'm going to go ahead and write in our whole square root symbol so we don't forget it in the end. So you would be putting your piece fingers right here, and that's going to tell you what values are now going to go here, here, and here, okay? So you're going to square those piece fingers, so that'll be 100 squared, and that'll be 1 plus 150 squared, minus, and this is where parentheses are going to be important in your calculator, you're going to have 2, and your 100, and your 150, again, those are your piece fingers, and you're going to have your cosine of 40. Extend that. Okay, now this cosine 40 is the angle that your piece fingers are sitting right around. So it's the angle between your two piece fingers. When we type this whole thing into our calculator, what we're going to get, and this is a good place for you to check to make sure you're using your parentheses right, underneath that square root, you should have 9,518.66, and of course that decimal will continue. Make sure that you are getting this correct radicand. Once you take the square root of that, we'll go ahead and we'll round this to hundreds, and we'll get 97.56. We're going to go ahead and put that now over here on our picture. So here's our 97.56. We've now got that side. Now what we need to do is we need to solve for one of these remaining angles. Now, there are some extra things that you could do if you look at this and you say, hey, Miss Bass, now I have a link. I have the measure of a side and I have the measure of this angle across from it. And you'd say, ooh, I have a link. Now, if you wanted to switch to law of sines, there's some extra work that you're going to need to do. So instead, so we don't have to do any extra work, we are going to repeat this problem using law of cosines again. Now, it doesn't matter which angle that we solve for. I'm going to choose to solve for angle A. So angle A is what we're going to solve for. So when we set this up, we're going to say cosine A. And now we're back to piece fingers. We want to make sure to do piece fingers again. So A is what we want, so our piece fingers are going to go here and here. They're going to surround the angle that we either want or know. So here's our piece fingers. Again, just like we did here when we squared our piece fingers, we're going to square our piece fingers again. Now this time we're going to have to use that number that we calculated before. So we're going to have 97.56 squared plus 150 squared, and we're going to square those piece fingers in the numerator, and in the denominator we're going to multiply them by 2. So I'm going to have a 2 and a 97.56 and a 150. And the only thing that we haven't yet done is this last piece right here. The side across from that angle A, we're going to subtract that square. So we're going to say minus 100 squared. Now, when you type this in your calculator, you should get cosine A. And if you properly type this in with all of your parentheses correct, you should get a decimal on that right-hand side of 0.7522. Now, important note here, this value needs to be a number less than 1, and it can be negative. So you might want to write that down. This has to be less than 1, but it can be negative. In other words, it needs to be between a negative, that should be a parentheses there. It should be between a -1 and a 1, okay? It cannot be more than 1, and it will not end up equaling 1. Now, to actually get the measure of the angle, we're going to do the inverse cosine of this. Remember, it's going to look like this. Our A is now going to become the inverse cosine of 0.7522. That's going to give you a measure of angle A of 41.2 degrees. We can put that now in our picture. And this should make sense. These two angles are almost the same because these two sides are almost the same. And then our remaining angle, we can find the remaining angle by just subtracting the remaining 2 from 180, and we will get our remaining angle of 98.8 degrees. So we've got 98.8 for that angle, 41.2 for that angle, and we have found our missing side.